is about the types of joints in the human body. As artists, we really only need to learn the synovial joints, like the shoulder and the knee, because they move. Joints that are fibrous and cartilaginous hardly move, and some, like the connection of the two pubic bones, don't move at all. When you're learning how to draw, pay attention to synovial joints, and keep your thoughts away from pubic bones. If you know where the joint is on this foot, you know that it won't do this, or this, when you stand on your toes. It will do this. We need to know the position of the joint to make squash and stretch look like the real thing. Synovial joints. There are 6 types of synovial joints. They have varying shapes, but the important thing about them is the movement they allow. Joints determine what position our bodies can take. We learn them to invent poses, and we learn the limits to stretch the limits. The 6 types of synovial joints are hinge, pivot, ball and socket, ellipsoid, saddle, and plane. Let's go through them one by one. The hinge joint. The hinge is a very simple joint. It allows movement only on one axis. Its structure prevents rotation this way or this way. The head of the bone wraps around the cylindrical head of the other, allowing a very stable rotation this way. Going back to the terminology from last week, the hinge joint allows flexion and extension. That's it. That's all it does, but it does it well. Like the hinges on a door, allow it only to open or close. The best example of it is the elbow. Here's the rotation on a simplified skeleton: flexion and extension. So, if the elbow only allows flexion and extension, how is it that we're able to twist the forearm? Well, let's take a look at the next joint, the pivot joint. The pivot joint also allows rotation at only one axis. However, it rotates along the long axis. A cylindrical bone fits into a ring of bone and ligament, like the radial ulnar joint just below the elbow. The cap on the radius bone fits nicely into this notch on the ulna bone. Ligaments complete the ring, holding the bone in place and allow the radius only to rotate inside of it. The result on the forearm is what we call pronation and supination. During pronation, the base of the radius rotates over and around the head of the ulna. The ulna stays relatively still. Remember, the hinge joint at the elbow prevents the ulna from twisting, so all of that twisting happens at the radius. And by the way, the distal joint of the ulna and radius is also a pivot joint. The combination of the pivot at the top and at the bottom creates that twisting motion for pronation and supination. The ball and socket joint. The ball and socket is the champion of all joints. Hooray for the ball and socket! Its structure is just like how it sounds, a ball inside of a socket. This simple and effective structure allows it to move in all axes: flexion, extension, abduction, adduction, rotation, and circumduction. The 2 ball and socket joints of the body are at the hip and the shoulder. The hip has a deep socket, which gives it stability but limits some range of motion. The shoulder joint has a shallower socket, which gives it greater range of motion but takes away some stability. Maybe that's why a dislocated shoulder is so common. Ouch. The ellipsoid joint. The ellipsoid joint is very similar to a ball and socket. However, the ligaments and its oval shape prevent rotation. but it still has the ability to rotate on two axes, which allows flexion, extension, abduction, adduction, and circumduction. Circumduction is just a combination of all the others in a circular motion. The ball, or oval head, also slides inside the socket. When it rotates along the wider plane, you can see how it pops out too much from the socket, so it slides back into center. A great example of an ellipsoid joint is the wrist, also known as the radial carpal joint. The group of carpal bones rotate inside the socket of the radius. The saddle joint. The saddle joint is similar to the ellipsoid, but the rotation is limited mostly because of the bone structure. The structure of the saddle is very interesting. Both bones have a concave and convex surface. Convex means the surface sticks out like a hill. Concave means the surface curves in like a hole or a cave. The concave plane of one fits on the convex plane of the other. It's like a 3D yin-yang, or a cowboy on a horse. The saddle makes the bottom piece, and the cowboy's legs make the top piece. The legs of the top piece, which wrap around the body of the bottom piece, allow a rotation this way. The body of the top piece can glide inside the legs of the bottom piece. So this unique structure allows the joint to flex, extend, abduct, adduct, circumduct, and very slightly rotate. An example of the saddle joint on the body is the carpometacarpal joint of the thumb. Let's see that baby in action. Finally, the plane joint. Not really as interesting as the others, but deserves our love anyway. It's basically two flat-ish surfaces, one on top of the other. These surfaces can glide or rotate. They usually come in groups, like the carpals of the hand and the tarsals of the foot. Ligaments hold these bones together, but might allow some rotation and gliding. Another plane joint is the acromioclavicular joint. That's the one between the clavicle and acromion process of the scapula. When we elevate the shoulder, the angle in here will adjust to keep the scapula vertical. The spine. I mentioned in the beginning that the cartilaginous joints are not important for artists, except for one big important case, the spine. We'll talk about that in the next lesson. Assignments. For this lesson, there's two assignments. The first assignment is to find these joints on yourself and study the movement. I've posted 6 close-up images of Skelly's joints in the description under this video. Your second assignment is to draw them as simple versions. When you try to put them into perspective, you might find it difficult, but I will have Marshall Vandruff help you understand how to do it. Post your drawings in the Facebook group at facebook.com/groups/anatomy for artists. Marshall, the perspective master, will help to critique your assignments in the Facebook group. Later, Marshall will do a demo to show you how to simplify your forms and move them around. Last week, we studied the language of anatomy. Just looking at a long list of terms can be daunting and difficult to remember. That's why I put together a PDF ebook that visually defines all these terms. This ebook is available as a premium feature at proko.com/anatomy. This week, I've included another PDF ebook showing which of the 6 types every joint in the body is classified as. And again, it's shown visually rather than just a list, so you can print these out as reference. Another premium feature you'll see this week when you log into your account is a 3D model of RoboSkelly. This is a skeleton with simplified forms. Simplified forms are a lot easier to understand, to remember, and are more practical to apply to your drawings. So you can zoom in and rotate around RoboSkelly directly in your browser. This will help you with the assignment this week and upcoming lessons when we study the skeleton in detail. To get all the Anatomy premium features, go to proko.com/anatomy. If you like this video, pass it on to your friends and classmates, and click this button here to subscribe to the Proko newsletter so you don't miss any new videos. Bye-bye!